Hello everyone! Welcome to Bitesized Science. My name is Jepna, and our video today, Cloudy with a Chance of Radiation, is about the radioactivity all around us. You might feel concerned when you hear the words radioactive or radiation. Radiation is just energy that moves from one place to another. While high amounts of radiation can be harmful, there is always some background radiation in the environment that we're used to. And many electronics around us use radiation. Microwaves heat up our food, X-rays help doctors treat patients, and the light and heat from the sun allows life to thrive here on Earth. These are examples of electromagnetic radiation, which move as waves. Another type of radiation involves tiny, energetic objects called radioactive particles that are released from the nucleus or center of atoms. We call this nuclear radiation, and that's what we'll focus on today. So, as Julie Andrews once said, let's start at the very beginning, a very good place to start. To understand nuclear radiation, we first must talk about atoms. Atoms are the tiny building blocks of matter. Human beings and everything you see around you are made up of atoms. There are many different types of atoms that make up our entire universe. Carbon, hydrogen, oxygen, just to name a few. But atoms themselves are made up of even smaller particles: protons, neutrons, and electrons. The nucleus is the center of the atom, made up of the heavy protons and neutrons, while the fast but light electrons orbit around the nucleus. This is a helium atom, which has 2 protons, 2 neutrons, and 2 electrons. Each element in the universe has a unique number of protons that gives it the chemical properties of that kind of atom. That number is its atomic number. That's how we know that this is helium and not oxygen or carbon. Scientists can represent different types of atoms using their chemical symbol. Carbon's chemical symbol is the letter C and includes 2 numbers, the atomic number on the bottom and the mass number on top. Carbon has an atomic number of 6 and a mass number of 12. The mass number of an atom tells us how many protons and neutrons it has. So, carbon has 6 protons and 6 neutrons in its nucleus. Altogether, this simple symbol tells us a lot about the properties of an atom. What do you notice about this carbon atom? What has changed in its symbol? Can you see that its mass number has changed? There are now 2 more neutrons in the atom's nucleus, so the mass number is bigger. It's now 14 instead of 12. This carbon atom is heavier than the carbon-12 atom and is called an isotope of carbon. It has the same number of protons, so it's the same element carbon, but it has a different number of neutrons. Many elements have isotopes, some more common than others, as larger isotopes can be unstable, and so will change into a more stable form of atom. Unstable atoms, like carbon-14, go through a process called radioactive decay to become stable and give off nuclear radiation in the process. The atom's nucleus decays or breaks down by shooting off or releasing a piece of itself in the form of small, energetic particles like alpha or beta particles. Once released, these radioactive particles carry on along their merry way, leaving behind a daughter nucleus that is a more stable and smaller atom. Radioactive atoms can also become more stable by emitting gamma rays from their nucleus, making an excited atom into a more relaxed one. Since this is happening at an atomic level, we can't see this happen, so how do we know that there are radioactive particles around us? One way is by using a very special instrument. A cloud chamber detects some of the background radioactivity in our environment and reveals the tracks left behind by radioactive particles, like footprints left in the sand. A cloud chamber is filled with alcohol vapor. As a particle, like an alpha or beta particle, zips through the chamber, it bumps into air and alcohol vapor molecules inside, giving away some of its energy. This allows some of the alcohol vapor to condense, turning from gas to liquid, and forming a trail made up of tiny droplets of alcohol, which shows the particle's path. The trails look like white, puffy clouds, like the condensation trails left behind by jets flying high in the sky. The trails or tracks in a cloud chamber come from different particles. So, by observing the different shapes and patterns of the cloudy trails, we can tell which particle is making which track. Alpha particles have thick, usually straight tracks, while beta particles can have thin ones, with lower energy beta particles having shorter, more crooked tracks. Can you spot any alpha or beta particle tracks? Other tracks in a cloud chamber can be made by particles from outer space. Protons and special particles called muons from cosmic rays, very energetic radiation from the sun, distant stars, or even supernovae, the explosive deaths of stars. These cosmic ray protons and muons pass through us without us even realizing it. Their tracks are usually short and almost vertical, straight up and down. Do you see any of those tracks here? Did you know that you are slightly radioactive too? Human beings are made up of many of the same building blocks of our environment, so our bodies also contain some radioactive atoms, like potassium-40 and carbon-14. Now think about how those atoms came about to make you up. Hydrogen was the first atom. Heavier elements than hydrogen formed inside stars, and even heavier elements like gold came from stars that have long gone supernova. Supernovae still affect us through the shower of particles from cosmic rays that pass through us. Those tiny white wisps in a cloud chamber hold some of the answers to some big questions, like who you are and what you're made of. Well, friends, that's all I have for you today. If you'd like to check out these cloudy tracks for yourself, do drop by the Discovery Center's Energy Gallery and see the invisible radiation that connects you to the cosmos. Thank you for tuning in. This is Jepna, wishing you all clear skies and reminding you to stay curious.